When discussing motion, one is bound to use the three laws of motion that Newton came up with around the 16th century. Now, note that these laws didn't come out till the 16th century. That makes them somewhat recent in terms of the existence of humankind, which is telling in terms of these laws, especially in terms of the first law, which is telling because it tells us that it was difficult for humankind to figure out how objects move naturally. It was difficult for humankind to understand the nature of motion. So it is important that you pay real close attention to this, because our natural intuition does not describe motion correctly. That's why it took humans a long time to come up with these laws of motion. Okay, we start here with Newton's first law of motion. It deals with the natural way for objects to move. What do we mean by natural way? When objects are left to their own devices, when there are no outside things to affect the motion, no outside forces to affect the motion. When left to their own devices, the natural way for objects to move is either not to move at all, stay at rest if they are not moving, or to move at a constant speed in a straight line. Move at a constant speed in a straight line, which is the same as saying move at a constant velocity. So the natural way for objects to move when they are left to their own devices is not to move at all or to move at a constant speed in a straight line. Which means if an object is speeding up, it's not moving naturally. It is not left to its own devices. If it is slowing down, same case. It's not moving naturally. It's not left to its own devices. What about if it is just changing direction? Same thing. It's not moving naturally. It's not left to its own devices. Think of cases like the moon going around the earth. That's not moving in a straight line, so it's not moving naturally. It's not left to its own devices. It must be affected by some outside forces. In the case of the moon, gravity. I push my phone on top of my desk. The minute it's off my hand, it's going to slow down till it stops. So it's not moving at a constant speed. It's not moving naturally. In that case, it's not moving naturally because of friction. I hold my phone off my desk and let go of it. It speeds up in the way towards the floor. So that's again not constant speed in a straight line. So it's not moving naturally. In this case, it's not moving naturally because of gravity. So if I see an object moving at a constant speed in a straight line, then I should understand that it is left to its own devices. It does not need something from the outside to keep it moving at a constant speed in a straight line. Or in other words, to keep it moving at a constant velocity. So objects that move naturally, they are subject to no net force. So here I'm becoming more precise in the use of the word force. I'm using net force. And I'll explain that in a minute. So objects that move naturally will have a constant velocity, so they will have no acceleration. So natural motion, when left to their own devices, there is no net force, no acceleration. So what does net force mean? Okay. So I have several blocks here. This block here is being pushed towards the right with a force of 10 newtons. And that's the only force acting on it. So that's the net force. That unique force, that unique 10 Newton force, is the force acting on that object. Now in this case we have two forces acting on the object. Both of them are pushing it towards the right. One is 10 newtons and one 6 newtons. So the two forces are ganging up on that object. And they are pushing in the same direction. So the net force is just, we sum them up, 16 newtons. That's the net force acting on that object. So this one is not moving naturally. This one is not moving naturally. Let's check this one. 10 newtons in one direction, towards the right, but 6 newtons towards the left. So in this case, the 6 Newton force is balancing part of the 10 Newton force. The part that remains unbalanced is 4 newtons towards the right. So we get that by 10 minus 6. So we have 4 newtons of unbalanced force towards the right. That's our net force. So again, this object is subject to a net force, so it is not left to its own devices. Now, what about this case here? I have a 10 Newton towards the right and 10 newtons towards the left. So the two forces balance each other out. So we don't have a net force because they balance each other out. This object is going to move naturally. If it is moving, it's going to keep moving at a constant velocity. It's going to keep moving at a constant speed in a straight line. If it is not moving, it's going to stay at rest. This is a similar case. In this case, we don't have any force acting on the object. So there is no net force. So again, this object is moving naturally. If it is moving, it's going to keep moving at a constant speed in a straight line. It's going to keep moving at a constant velocity. If it is not moving, it's going to stay at rest.